Many industrial processes depend on the controlled use of heat. To better understand the vital role that heat plays in the process industries, you need a good grounding in the principles of heat and heat transfer. One of the problems in understanding heat is that you can't see heat directly, but you can see the effects of heat. One effect is seen on this thermometer. The temperature is rising, indicating that heat is being added to the water. Here's another example. This container is filled with air, a gas. Connected to the container are a thermometer and a makeshift manometer, which indicates pressure changes. When we heat the air in the container, there are two main effects. One effect is an increase in temperature. The other is an increase in pressure. As the air's pressure increases, it pushes the liquid in the manometer, changing its level. In the two examples we just saw, the effects of adding heat were obvious, changes in temperature and changes in pressure. The addition of heat caused a change in the properties of the substance. Another possible effect of adding or removing heat is a change in the state or phase of a substance. All substances exist in one of three phases of matter: solid, liquid, or gas. If we heat ice, a solid, of course it melts and changes into water, a liquid. So adding heat has caused the ice to change its state from a solid to a liquid. Then if we heat the water, it boils. So the heat causes the water to change its state from a liquid to a gas, steam. The effects of heat are all related to changes in molecular motion. For example, when heat is added, the motion of the molecules that make up a substance increases. When heat is removed, molecular motion decreases. All solids, liquids, and gases are made up of molecules, and these molecules are constantly moving. Since molecules are always moving, they have kinetic energy. Kinetic energy is the energy of motion. One way to measure kinetic energy is in terms of temperature. Basically, temperature is the degree of hotness or coldness of a substance measured on a scale. As you know, temperature scales usually indicate units of degrees Fahrenheit or degrees centigrade or Celsius. At the molecular level, temperature is a measure of the average molecular kinetic energy of a substance. That is, temperature is an indication of the average molecular motion in a substance. Another way to look at temperature is in terms of intensity. The faster the molecules of a substance move, the more intense the motion is. The greater the intensity, the higher the temperature. Although the molecules in a substance are always moving, some molecules may move faster than others. Boiling water illustrates this principle. With boiling water, some of the water molecules move fast enough to overcome the molecular forces holding them together. When water boils, some of the molecules move fast enough to escape the water as steam. In general, boiling can be defined as the condition at which the molecules of a heated liquid become active enough to escape the liquid. In the case of water, the temperature has to reach 212 degrees Fahrenheit to cause the molecules to move fast enough to leave the water as steam. At this point, we'll turn our attention from temperature to heat. Heat is a form of energy called thermal energy. In a sense, heat is the amount of thermal energy, and temperature is the intensity of the thermal energy. We'll use two beakers of water to illustrate the relationship between temperature and thermal energy. This beaker has only half as much water as this beaker. The temperature in the beaker with less water is 110 degrees Fahrenheit. The temperature in the beaker with more water is 100 degrees Fahrenheit. The beaker with more water contains more thermal energy and therefore more heat than the other beaker. Because there's more water, it takes more heat to raise the temperature of this water than it takes to raise the temperature in the beaker with less water. Although the beaker with less water has less thermal energy, its energy is more intense than the energy in the beaker with more water. The average molecular motion in this beaker is faster, so its temperature is higher. The two units generally used to measure heat are the British thermal unit, or BTU, and the calorie. A BTU is the amount of energy needed to raise the temperature of 1 pound of water 1 degree Fahrenheit. A calorie is the amount of energy needed to raise the temperature of 1 gram of water 1 degree Celsius. Heat is a form of energy known as thermal energy. Thermal energy can be either stored in a substance or transferred from one substance to another. There's an important law of energy called the law of energy conservation. This law states that energy can be neither created nor destroyed, only altered in form. Basically, this law means that all energy has to be accounted for. There are a couple of ways the law of energy conservation works. As an example, fuels contain chemical energy. When fuel is burned during combustion, heat is generated. This heat is thermal energy. So the process of burning fuel alters the form of energy from chemical to thermal. Now let's say the heat from combustion is used to heat a process fluid flowing inside furnace tubes. Much of this heat from combustion, or thermal energy, is transferred to the process fluid. Since no furnace operates at 100% efficiency, not all of the heat is transferred to the process fluid. Some of it may go up the stack. Some of it may be absorbed by furnace equipment, but all of it goes somewhere. That is, all of the thermal energy is accounted for, so none of it is destroyed. In this topic, we covered some of the fundamental terms and concepts pertaining to heat. We looked at the effects of heat, and we saw how temperature and thermal energy are related. We also discussed the law of energy conservation. Now's a good time to try a few practice questions. A possible effect of adding or removing heat is a change in the state or phase of a substance. All substances exist in one of three phases of matter: solid, liquid, or gas.